Hello, grade 5-6. I just wanted to take this time to review with you what happens to numbers when you multiply by 10, 100, or 1000. So let's get started. I'm going to show you some numbers, and as the numbers are coming up, I want you to think about what patterns you're seeing in these math equations. So in this first one, we have 3 times 10, 3 times 100, and 3 times 1000. So hopefully you see a pattern there. Let's see what this pattern looks like with a 2-digit number. 26 times 10, 26 times 100, and 26 times 1000. And now let's see with a 3-digit number. Hopefully you see that there is some kind of a pattern. So specifically, I'm looking here at the number of, when I see a 0 in the 10, I see a 0 here, a 0 in the 10, and a 0 here. So let's draw a line across this group of numbers and across this group of numbers. So when I do that, you could maybe see that when there's a 0 in the 10, we add a 0 to this first number. Same here with 438, multiply by that 10, and we have an extra 0 on the end. So let's now take a look at the second group of numbers here when we multiply by 100. So now we're multiplying by 100 with 2 zeros. And so in that 3, we now have the 2 zeros added on. 26, here's the 2 zeros. And with 438, 2 zeros here. And I'm guessing now that you've seen that pattern, you'll see what will happen when we multiply numbers by 1000. We're going to add 3 zeros to the end of each of these numbers. So we could maybe make up a rule that when you multiply by 10, you're going to add 1 0, just like we saw here with all of these numbers in the first row. When we multiply by 100, you'll see that we added 2 zeros to the number that you're multiplying by. And when you multiply by 1000, you're going to add 3 zeros to the number that you multiply by. And this is when we're multiplying specifically with whole numbers. And this should be review of things that we've done before. So the question is now, well, does this work with decimal numbers? And so let's take this first rule that we had. When multiplying by 10, add 1 0. So let's try it. We have 0.4, and we will multiply that by 10. When we do that, we should, in using that theory or using that rule, we would get 0.04. Here is our 0 in the 10, and we've added that on to 0.4. But what do I know about 0.4? Isn't 0.4 equal to 0.040? That doesn't make any sense. Okay, well, maybe we could check this with an array. Let's first start by showing what is 0.4 on this picture. So if I color in 4/10, so here I've got my 1/10, 2/10, 3/10, 4/10. And what 0.4 times 10 means is that I need 10 of these. Just like groups, 4 times 10 is 10 groups of 4. So we want 10 groups of 0.4. And here we go. Now 10 groups. And they all have 4/10 colored in. Okay? So if we're going to multiply them by 10, I need to join them up so I can see how much I actually have. So I'm just going to do a little bit of rearranging here. And I'm going to move this one here, and let's take this one and these 2/10 to make a hole down there. So I've got 2 holes so far. I'll move these 4/10 over here, these 4/10 here, and then I'll split up these last 2. And when I move all of these tenths around, I have some empty trays. So I'll just ignore these ones. We don't need them anymore. They're all empty. And I can see now that instead that what I actually have when I multiply 0.4 times 10 is I have 1, 2, 3, 4 whole numbers. So in actually, what this number sentence should say is 0.4 times 10 is equal to 4. And if I look carefully at those two numbers, 0.4 and 4, I'm seeing that there's a relationship there. So let's investigate this a little further. Let's look at the pattern now. If I get a calculator out, or if I had enough blocks to work all of these out, I know that 0.4 times 10 is 4. If I had 100 4/10ths, if I group them all together, I would get 40. Or in a calculator, I would put in 0.4 times 100 is equal to 40. And here is 0.4 times 1,000. So I am starting to see a bit of a pattern. I do see some zeros here, so let's take a look a little closer at these numbers. Here, I've got 2 zeros, and this time I only have 1. This one I had 3, but I have 2 on this answer. This one I had 1, and I don't have any. Okay, let's try a decimal number with a whole number. So if I put this in a calculator, or if I had blocks and I was able to have enough of these, I would find that 5.2 times 10 is 52, 5.2 times 100 is 520, and 5.2 times 1,000 is 5,200. So again, I'm not seeing any 0 in this one, but I see 1 here. There's 2, and 3 there, and 2 here. Let's try a 2 decimal number, and here's the pattern. So what I'm actually seeing though, if I disregard the zeros and I think about just simply the decimal, if I think about the decimal here, 0.4, in 4, it's now here. If I multiply, now I see a decimal here. So in this case, it's moved 1. In this case, the decimal has moved 2. In this case, the decimal has moved 1, 2, 3. And so let's look over here at this whole number. The decimal used to be here, 5.2, and now it's gone to the end of this number, so it's moved 1 decimal place. And here, 5.2 again, and it's gone 1, 2. It's to here now, 2. 5.2 here, it goes 1, 2, 3. Let's check our 2 decimal number now, 7.63. So the decimal used to be here, and now I can see it here. So it's only moved 1. In this one, we can see the decimal has moved 2. And in this one, the decimal has moved 1, 2, 3. So I wonder if we could come up with a new rule that would work for decimal numbers when multiplying by 10, 100, or 1,000. So our old rule used to be when multiplying by 10, add 1 0. But look at these ones. What did we actually do? Well, we can see that we moved the decimal 1 place to the right. So when multiplying by 10, we're going to change that to move the decimal 1 place to the right. When multiplying by 100, our rule could be that we move 2 decimals to the right. And then when multiplying by 1,000, we have 3 zeros, move the decimal 3 places to the right. So it's a pretty easy and fast way to remember, instead of getting out a calculator or using the blocks, how to multiply by 10, 100, or 1,000. Let's do a few quick examples. I'm going to show, let's have our rules up here. So when multiplying by 10, move the decimal 1 place to the right. When multiplying by 100, move the decimal 2 places to the right. And I'm hoping that you're seeing this pattern here, 1 0, 1 to the right, 2 zeros, 2 to the right. And if we go 3 zeros in 1,000, 3 to the right. So that's a nice, easy way to remember. So here's an example. If we had 0.89 times 10, I want you to think about in your mind, what should that equal? I'll give you a couple seconds to think about it. If we multiply that by 10, we're going to move that decimal 1 place to the right, and we will end up with 8.9. Now let's try a new example. 7.54 times 10. Thinking about our rule, what's this going to look like? Move that decimal once to the right, 75.4. Let's try one a little more difficult now. This one has some zeros in it. So if we had to move this decimal once to the right, it's not going to go away completely. So instead of 0.03, we're just going to have 0.3. Let's try one with 100 this time. So now we have 2 zeros. We move the decimal 2 places. 2, and our answer will be 4,102. Next one, also multiply this one by 100. Now this one is a little tricky because if I want to move this decimal 2 times, I can only move it once. But we should remember that after every number, there's a 0 placeholder we can put in there. So we're going to move it 2 times, and we should have 310. And let's try this one. Now this one's very tricky. We have to remember that 0.9 is equal to 0.90000. And if we remember that and we move that decimal 3 places, we will get 900. And let's try this one, 5.3. So same thing again, we have to remember that 5.3 is the same as 5.3000. We could keep going on forever and ever, and we're going to move that decimal 3 times. 1, 2, 3, and you should predict your answer is going to be 5,300. I hope that has given you a good idea of what to do, remembering these rules over here. You're going to need that for your work today. So good luck. If you have any questions, you can email me. See you guys later.